My name is Francisco Tolmasky. I'm part of a company that I formed with two of my college friends called 280 North. We have three products kind of out there today. You may or may not have heard of them. On the left is 280 Slides. It's kind of like PowerPoint or Keynote on the web. On the right is a product we just announced, but we have not launched yet. It's called Atlas. It helps you build kind of desktop class applications for the web. And in the middle is what I'm going to be talking about today, which is the Cappuccino framework, which is a set of kind of open source libraries that we released for building these kind of desktop class applications for the web. And specifically today I'm going to be talking about 0.7, which is the latest version, which we have not shipped yet, but the beta is available. And I kind of want to talk about some of the new stuff that's coming with that. But before I do that, I want to give kind of a little bit of background on the framework itself. I'm not sure how many of you are familiar with it, so I'll just kind of explain it a little bit. And usually what I do is kind of give a primer of, kind of information on how we do things in Cappuccino. But today I'd like to do it a little bit differently and kind of give you the background of what led to creating this framework. And it kind of started back in 2005. This is what I'm talking about specifically, Objective-J. Sorry. It kind of started back in 2005. I was still in college then, and we kind of started saying, hey, this web thing is catching on. We should make some apps for the web. And at the time, we had not thought about Cappuccino or Objective-J or anything. We were just, we were really big on the open web, and we're just going to use JavaScript, et cetera, et cetera. And Mozilla just kind of announced some new nifty things that they added to JavaScript. One of them was the forEach thing that the forEach method on the array class. And you all know what forEach does. And I said, oh, that's really cool. Like, JavaScript is getting better. Like, I had not touched JavaScript at this point for a very long time. I had done mainly Objective-C and C++. So I was just coming back to the web. And I was saying, oh, it seems like things are really coming along. I'm going to be a good member of the Open Source Society and implement forEach for WebKit. So the very first piece of code I ever committed to WebKit was all those Mozilla functions like index-of and forEach for the array class. And I was like, all right, now we got WebKit and Mozilla. I'm sure IE will put this in within the year, and we'll be all set. This will be great. So 4 years later, IE still does not have forEach. And we're not talking like complex code here. I'm not saying like, oh man, IE still doesn't have JIT compilation. No, we're talking about forEach. This is a for loop. Literally, all you have to do to implement this is write a for loop. And we still don't have that in IE. And that kind of set the mantra for what, resulted in Cappuccino. So that was kind of what Mozilla called JavaScript 1.6. And then we started having a lot of this kind of similar effect. Another one was ECMAScript 4. In all honesty, had ECMAScript 4 existed in 2005, we probably would not have done any of what we did. Like, I have some problems with the ECMAScript 4 specification, but they're purely little annoyances. Like, I think it's a perfectly fine language. And had it existed, I would not have felt the need to invent a new language or anything. We would have just made apps with this. But that didn't happen, right? I mean, for like a solid year, we were told, ECMAScript 4, it's coming. This is the real deal, guys. And they hosted classes on this. Mozilla, had the reference implementation. And then all it took was one meeting for this thing to get abandoned completely. And then, now my history is a little fuzzy on this part because I kind of stopped paying attention, but I believe this is the one that came after it. Kind of went backwards a little, and I think this is called Harmony. It's kind of a few of the things from 4 and a few of the things from other places. And I just checked Wikipedia last night, and there's now ECMAScript 5, and I have no idea what this does. But the thing that gets to me is like every time they announce a new one of these ECMAScripts, like people get really excited, like, oh man, things are going to change this time, right? And the same image always comes to my mind when people have this reaction, which is this. Like, the standards bodies are like, here comes the new JavaScript, guys, so everyone gets excited. Whoop. So I think I speak for everyone when I say, good grief. And this is really unfortunate just because if you kind of look at the landscape outside the client-side web, things like Ruby, Python, Java, Scala. It's really exciting out there for a number of reasons. One, I don't know if you guys read Reddit or not, but it seems like someone invents a new language like every week. And maybe the language won't survive, but like there's lots of really great ideas and they all cross-influence each other. And Scala is relatively new and it's a really great language built on top of the JVM. But additionally, within each language, like so much is being done. Like, the difference between Ruby 1.9 and 1.8 is so great. And they're always trying to add things to Python, etc. And I really wish we had that on the client-side web. And we don't. And it's kind of funny, like we call it the open web, but it's really closed to us, the developers. Like very rarely do the standards bodies come and ask us, the developers, like, what do you need? It's very much we know how to make it. You guys just, we'll figure it out. And that's really distressing to me. Again, coming from these communities where I can say, hey, I want this feature, and a couple weeks later it's in there, and then to not have that. So basically there's kind of two ways to approach this problem. Given that JavaScript is not going to change, like we can't go in and change JavaScript in every browser, the only option is really to build something on top of JavaScript. And what most people do is precisely that, right? They build some library that kind of makes JavaScript insane. We had kind of a different approach, which was to build a whole language on top of JavaScript. And we call it Objective-J. And this is kind of the stuff it does. I'll get into it in a little more detail in a second. But I want to tell you why we decided to make a language as opposed to a set of libraries. Like every single language is equally dynamic. Like if you want garbage collection in C++, you can get it. You just have to implement it yourself. And you make the garbage collected object class, and as long as every single object in your application subclasses that, your whole program will be garbage collected, right? If you want first-class function objects in C++, you can do that too. Just make the functor class. You want classes in C? Fine, write the wrapper functions. And this is what people used to do, right? Back in the C days, before we had C++ and Objective-C and et cetera, people actually wrote wrapper functions around structs to simulate classes in C. But when we did that, no one said, see how elegant C is? You can do just about anything in C. No, people were like, man, this really sucks. This should really be a language feature. And that's the way I feel about a lot of the things that people are currently doing with libraries today, specifically trying to fix kind of like the class problems in JavaScript. I think there's a pretty clear difference in your code between the things that actually achieve goals for your application, like taking the cosine of a number, right? Like that's something that has to do with the direct goal of your application, versus the meta work of your application, such as creating objects or classes. I think functions and libraries are there to provide you with these kind of tangible functions that do tangible things, like draw a circle or calculate the cosine, etc. And the language should handle all the meta work. And the reason is because it's nice when you have visual distinction between, like, I'm creating a class versus again taking the cosine of something. And it's not just for humans. Tools really benefit from this too, right? Like if you have actual syntax constructs for classes and that sort of thing, then your tools can correctly syntax highlight it and make the little pop-up menus with all the methods, etc. The other problem is that since today all these kind of meta features are considered library domain, basically every single JavaScript library that comes out is doing the same thing. They all have their own kind of unique class structure. And that's really unfortunate because I shouldn't have to commit to prototypes classes just because I'm using the prototype library, or Dojo's classes because I'm using the Dojo library. So what we really wanted to do was say, hey, these are two separate problems. There's the problem of creating applications, and then there's the problem of writing code. So let's kind of separate this out. And Objective-J, all it's meant for is to solve what we consider to be the holes in JavaScript, which I think a lot of people consider to be holes in JavaScript, which is the reason we have all these ECMAScript specifications in the first place. So the first one I think is a no-brainer, right? Code importing. Like, I'm still surprised, like, how many companies have dedicated teams that basically manage dependencies in an application. Like, this doesn't exist anywhere else. Like, no one else has like job title of managing .h's for like a C++ like application. Only in JavaScript, where you can't clearly identify the dependencies, and so you have to put them in the right order and then concat them together or whatever. So one of the main things that Objective-J does is allow you to import code in the same way that you would in Java or C++. Just import and then the file name. And the reason this is so much better as a language feature versus a library feature is that, so this is a bit technical, but if you import code and then you write code and then you import code, right? So import code, import. If it's a function that actually goes and fetches the file, which some libraries do, right? I'm not saying we're the only people that have code importing, but in other libraries, it's just a function. You say, import this file, and then it fetches it and evals it. If you do that, you have to block execution until that's done. And now, I'm not saying that the actual fetching of the file is synchronous. It's still asynchronous. But you can't continue to work until the file is fetched and executed. So the nice thing about having this be a language feature is that we actually can look through all your code, see all the files you're going to import, and import them ahead of time. So we're maximizing all the AJAX requests up front because we are a language and we can see exactly everything you've written. The second thing we add to JavaScript is classical inheritance. Now, if you guys want to, go to a cigar bar later and discuss the philosophy of prototypal versus classical and blah, 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 that's fine. But the reality is a lot of people are really used to this form of inheritance. At the very least, it's as good as prototypal. And UI libraries really, really function well with classical inheritance. And I think this has proven itself because a lot of what libraries do today in JavaScript is kind of emulate this classical behavior. Again, the unfortunate thing of it not being a language feature is that a lot of these libraries don't get it quite right. They don't have proper support for calling superclass implementations of methods, etc. We get that all just fine. The other feature we add, the next two are kind of related, is dynamic dispatch and method missing. If you guys are coming from the Ruby world, you're probably familiar with this. Just long story short, you can basically intercept any method call and do whatever you want with it. So you can reroute it and do whatever and do something different, or you can swap classes at runtime, etc. But by far, I think the coolest thing about Objective-J is that it is completely open source. And to give you an example of what that means, we open sourced this in like September or something. And immediately a lot of people said, oh, I really wish this had the automatic setter-getter generation that Ruby has. And a week later, we added that language feature. And you're just not going to get that if the language itself isn't open source. So the other cool thing is that you can take Objective-J and if you disagree with some of the decisions we made, you can change it. You can create a whole new syntax. You can fix a bug that we deemed not important enough for us to fix, etc. Another really interesting thing is that the underlying runtime, since it is completely written in JavaScript, actually opens the doors for writing a lot of different languages, not just Objective-J. I don't know if you guys are familiar with Mac Ruby, but it's basically a Ruby implementation on the Mac that's written on top of the Objective-C runtime. And I know that there's someone trying to do the same thing with, I don't know, Objective-J Ruby or something. But since the Objective-J runtime is exactly the same as the Objective-C runtime, they're trying to do the same thing, kind of bringing Ruby to the client side on top of our runtime. So I think that's really exciting, the fact that basically it's a set of features, kind of small talk-like features that you can use for any language. We happen to build the first one, which was Objective-J, but you guys can go and kind of start going nuts. But one of the really important things about Objective-J is that it's what is called a strict superset of JavaScript. And that means that every valid line of JavaScript is a valid line of Objective-J. So all existing JavaScript libraries are going to play nice with Objective-J. So I'm not talking about Cappuccino, just Objective-J. If you still want to use jQuery, if you still want to use prototype, whatever, you can use it with Objective-J. That's fine. So this is just kind of this is our take on JavaScript 2, putting it out there. If you want to start making libraries that have kind of this classical inheritance feel and have these features, you can do that. So the other side of the coin, of course, is the Cappuccino framework itself. And I'm going to kind of rewind again to when we started working on this stuff. I mean, this is still true today, but what I like to say is that the web is this spectrum of different kinds of applications. On the left-hand side, you have completely static web pages. like New York Times. We're getting kind of less and less of these, but it's very much the original vision of the web, a bunch of documents connected by hyperlinks. In the middle, you have things like Amazon, which is, again, a bunch of documents connected by hyperlinks, but no one can deny that this is actually an application, whereas New York Times really isn't. You can buy stuff, etc. I don't need to convince you guys. Then you have things like Facebook, which really blur the line, right? Is it a traditional page? Well, yeah, everyone has their own page, but each page can have multiple applications in it and be incredibly dynamic. So, Facebook is a really, really unique thing that only the web was able to kind of enable. And then on the very right-hand side, we have things like Google Maps. And at the time that we were writing all these frameworks, I think Google Maps may have been like the only one. But basically, these are things that are competing head-on with what is traditionally in the desktop space. And when we kind of started writing this stuff, most of the libraries kind of focused on that middle section, like adding dynamic behaviors to websites versus creating a full-blown application. And I think that that's still mainly true today. I think there are definitely a lot more libraries that do what we're trying to do, kind of make full-blown applications. But I don't think there's any library that kind of handles the whole spectrum. I don't think that any library would ever be able to do that well. So what we decided to do was to make a library that just deals with building these kinds of applications. Just on this right-hand side, and again, some examples are R280 Slides, Meebo, and Google Maps. And I think if you look at kind of the big examples of these websites, it's clear that we're still not there yet framework-wise. Like, if you look at Meebo, I mean, what everyone's doing is kind of rolling their own framework. If you look at Meebo, a large part of their company is dedicated to managing their UI framework, which a company that makes a chat client really shouldn't be focusing on. And that would definitely not be the case in the desktop world, right? They wouldn't have some guy that's figuring out how to draw windows. Obviously, Google can just buy 50,000 companies and but what I mean to say by that is that they are also not using a public framework. They are doing it on their own. Zoho's doing the same thing. Obviously, we did the same thing in open source stars. So I think it's pretty clear that there's still a pretty big void in this space. And again, I wanted to focus on the fact that Cappuccino is designed solely for this. And usually this is where people come in and say, no, the web is totally different than the desktop. You don't get it. Everything's like one of these middle apps. And I do agree that it's a lot fuzzier than all the way on the right or all the way on the left. But I think that there are some really clear-cut cases. And a good example of that is Lacoste.com. So Lacoste, makes clothing, and this is their online store. This really should be a web page, but instead it's this humongous Flash monster which takes approximately 50 years to load. And they sell like 3 total products, and yet they somehow find a way to have 50,000 hierarchical Flash menus that you have to navigate through. And then when you finally find that pair of pants that you want, you can't even email the link to anyone because, again, it's a Flash app. So I think this is a perfect example of something that shouldn't use Cappuccino, shouldn't use Flash, should use traditional JavaScript and HTML, like Amazon. But the opposite case exists too. MapQuest is very, very traditional web, kind of pagey, and it really shouldn't be. You type in the address and it takes you to a new page, you get the map. If you want to get a different map, you have to type in the address again, refresh again, and it all feels very slow. It feels very counterproductive. As opposed to Google Maps, of course, which you just type it in and you get the results immediately. So again, I think there are some cases where it's very clear that this is kind of like a desktop app, it just happens to be in the browser. So what we decided to do was, we know that making APIs is hard, so we just said, let's just steal the best API that exists. And of course, we were Mac programmers, and we feel very strongly that the Cocoa API is a really, really good one. I think it's hard to deny that the stuff on Macs looks pretty darn good, and that's not despite the API, it's because of that. And similarly, that same API exists for the iPhone, and the stuff on the iPhone looks pretty darn good too. And in our minds, this has kind of helped Cocoa prove its chops, right? You had something that for 20 years was solely used on the desktop, and then they turned around and kind of blew the doors off with the phone. So I think that kind of demonstrates that this is a pretty powerful API that can do a number of things. So what we did was, it's actually an open standard, it's called OpenStep. So we took that and we threw it on the web. So now the same way that you make apps for the Mac and the iPhone is the way that you can make apps on the web. So I'm going to give you a quick example. This is our app, 280 Slides. So again, the idea is to create this kind of desktop feel. So we have kind of built-in search. So you can take in media, and we have like quick look and stuff like that that you have like on your Mac. And you can do just about anything you want, and this works in IE and Mozilla and everything. And this is all using exactly the same technology as you would on macOS 10. It's called core graphics, and you don't need to worry about whether you have CSS transforms or not. It's just going to work, and you can use copy paste, as you can see, and all from the keyboard. And I also have undo and redo, that sort of thing. And we have movies. On JSConf 1, which goes against the suggested JSConf wireless. But there we go. So you can quick look these two, and so load up the YouTube movie very slowly, sorry. But you guys can believe me that that's loading. Oh, there it is. There you go. Don't have to believe me. So again, everything's supposed to be very drag and drop, and it works exactly like the desktop. Copy paste should work on everything, not just text, etc. And this thing is auto-saving constantly based on my undo stack. So if I have undos, that means that my document is edited, so it knows to automatically auto-save. And that's kind of the thing that this framework does for you. It kind of handles all that sort of behavior that you get for free on the desktop. So let me go back here.
That's built in Cappuccino.
Yeah. So yes, that was built in Cappuccino. So I'm going to talk about the things we're adding for 0.7. So one of the things that people kind of have complained about with Cappuccino, and rightfully so, is debugging. Now, debugging in JavaScript pretty much sucks, but it's a little bit worse in Objective-J currently. So that's pretty bad. And a lot of people thought that this was because we were like abstracting away JavaScript or something, but that's not the case, even to our surprise. It just happens to be that we at 280 North are particularly good at exposing latent bugs in existing debuggers. So the code we made, like if you did in normal JavaScript, it would have the same effect. So let me give you some examples. The first one is, actually I'm going to focus entirely on the profilers, because that's where we did most of the work. So if you profile Objective-J code, you get something that looks like this. I'm sure all of you have run into this at some point or another. Basically, all the interesting functions are question marks, like, I don't know what this is. And that makes it really, really hard to profile, because we have, thousands of methods, and one of them is really slow. I knew that already. So that's definitely a problem. And this is Firebug, by the way. And a lot of people don't know this, but Safari also has a profiler, and we also don't work really well there. I don't know, can anyone tell what's wrong? I'll give you a hint. I should be making Objective-J message send faster, because it's taking up 500% of the profile. So clearly, all this was pretty useless for our needs. But again, these are all clearly bugs that would happen in any library. There's no magic that we put in there that makes the profiles show up as 500%. So the kind of cool thing about our team is, we know the WebKit people pretty well, and this used to be our day job. We all used to work at Apple. So we got together with them, and kind of in the last 2 weeks, we said, let's really tackle this problem. Let's make, debugging Objective-J, at least in WebKit for starters, just an awesome experience. And so we did a lot of work on the Safari inspector, and a lot of this work you're going to get whether you use Objective-J or JavaScript. We added some really cool things. So the first one that we tackled was this problem with anonymous functions. So the way you get this kind of anonymous function, I don't know what you're talking about thing, is when you create these functions without names, right? The profiler doesn't know what to call that, so it just says question mark or anonymous function. Now there's a traditional technique to kind of circumvent this problem, which is, just give it a name. And that works. So in this case, that would work. But there are other problems that are related to that. For example, this is kind of if you do a traditional JavaScript classy thing. If you run this through Firebug, you're going to get this, which is not very useful. I mean, okay, yes, one of them is slow. I don't know which one. So there's a general problem with how functions are named in profilers. And this comes from the fact that functions don't really have names. The function exists in the ether, and you have a variable with a name that points to that function. So a lot of the profiler code is trying to do tricky things to try to figure out what name you want to see. Unfortunately, you can never be tricky enough because JavaScript's pretty dynamic and you can always trick the profiler. And so one really good example of that is this. If you have a function that generates functions, you're never going to be able to name all those generated functions very well, right? So that's how it's going to show up in the Safari profiler, right? Useless, as we said. And even if I do this, that's not going to help because now they're all going to be called iterating. So unless you do some sort of ridiculous eval creation of the function, you're never going to have a very good name for it. And obviously, you don't want a huge performance hit just to be able to name a function. So we talked to the WebKit people a lot about this, and we came up with a pretty good solution. We added a new property to the function object. It's called display name. And now you can manually set it, and it'll use that first before any of its little tricks. So for example, what we do here is you create a function, and then you set its display name. And if you look in Safari, there, very nice. I see the function with 1,000 iterations is the slowest one. That makes sense. And the really cool thing about that is that it makes Objective-J methods first-class citizens in Safari. So when you use Objective-J, you're going to get a stack trace that looks exactly like Objective-C on macOS 10. So we think that's really cool. Additionally, we fixed a bunch of these bugs that resulted in the ridiculous amount of percentages and so forth showing up. So I think the Safari profiling experience is really the best right now, and I'm going to show you why. What makes Safari profiling so cool is that you have a number of ways to look at your code. So right here, we've been profiling the application did finish launching method of our application. And in this top-down view, you kind of see everything that happens in your program. So obviously, since we profiled application did finish launching, 100% of the profile took place in that method, right? So if we now uncollapse that tree, we see all the methods that got called inside of it and how they got divvied up. So you can kind of start, following the trace of your program. So this is kind of cool, but it's actually not as useful as what Firebug currently has, which is kind of the flat list. So in Safari, that's called the bottom-up profile. And if you don't uncollapse the triangles, it looks exactly like it would in Firebug, right? You have a flat list with the slowest stuff on top. You can sort it, obviously. So the problem with the flat list, though, is that you're missing a lot of subtle information. For example, if we said, oh, set frame size is pretty slow, it's number 2, I might spend a lot of time trying to optimize set frame size. And I might rack my brain over it for a long time and say, man, this is just a for loop. There's no way I can make this any faster, which is where this little tree comes in, because the tree shows you a reverse or inverse backtrace of your code. So basically what this says is set frame size got called from these 4 methods. Now you'll see something really interesting here, which is set frame size was only slow when it was called from size to fit. It's actually really, really fast in all the other cases. So it's not really set frame size that's slow, but some sort of dynamic between size to fit and set frame size. So, perhaps size to fit blows a cache that set frame size relies on, and you wouldn't really know that. You wouldn't really know that unless you had this kind of view, and you can go all the way down. So this is really cool, I think. So again, Safari profiling is working really well. This is something else that's cool. We have these buttons called focus and exclude. So if you want to get rid of every instance of a function in your profile, I already know I can't make that any faster, you can just get rid of it. And if you want to focus on just one function, that becomes 100%, and you can focus on that subgraph. So debugging in WebKit's going to be really great. I just got this code checked in last night, so tomorrow's nightly should have it, which means debugging in Safari is going to be really great when Safari 4 ships, which means that debugging with Chrome is going to be really great as soon as they pull in those changes. So we're really happy with the way that's working out. What we're doing next is we've already actually started working on these same patches for Firebug, mainly the display name thing. Doing the kind of tree thing is a bit harder. I just don't know enough about Firebug yet. The other thing we want to do is build more of these tools. We want the exact same tools for profiling memory, basically. And also, we want to explore this idea of dynamic interaction between the debugger and code more. So this kind of display name thing is kind of just the tip of the iceberg, right? Like the idea that you can tell the debugger certain things. And we've got some pretty interesting things we're working on in that regard. So the other thing that's coming in 0.7 is themes. I'm actually going to skip through this because I guess I don't have a lot of time. Or do I? I may. So I guess I'll just blow by this really quickly. So we added themes to the latest version of Cappuccino. That's the class that handles it. That's not what's really important. What I wanted to mention is that not only do we think it's really important to have a theming engine, but we think it's really important for your stuff to look really, really good by default. So we hired a professional design firm. Their name is Sofa. You may be familiar with some of their products. They also made the Cappuccino logo for us. And we kind of assigned them the task of making a really, really beautiful theme that looks good both on Windows or Mac, IE, whatever. And they did a really great job. It's called Aristo. You run it on Vista, IE, and it kind of feels like Windows. And you run it on Safari Mac, and it kind of feels like Mac. And it doesn't feel at all like Linux when you run it in Linux, but I think that's a good thing. And the other really cool thing about that is that we're completely open sourcing this UI. And I don't mean we're just throwing the PNGs out there, but we've taken all the Photoshop files that that they made over time, and we're going to dump that all into the GitHub tree as well. So you can go in there and kind of see how they develop their art. You can learn from their skills, et cetera, et cetera. We want kind of the same open source experience for the artwork in Cappuccino as for the code. So we recently announced this thing called Atlas, and it kind of allows you to build applications for the web. But what a lot of people don't know about is that you can kind of already do this with the 0.7 beta using a tool called nib2sib, which I'll show you right now. So if you guys have Macs, I don't know if you do. Hopefully you do. There's a tool called Interface Builder. That's what you use to make applications on the Mac. And there's these interface files called zibs. Launch that up. So basically, you just have kind of a little UI builder tool. And what we've done is created a converter that converts from their zibs to our equivalent format. So I'll show you what that looks like. I'll do this kind of empty thing first. You just run the tool on the file. There we go. And so this is just an empty window, right? That's all we had. So let's actually put some stuff in there, and you can kind of see how this works. So if we can go grab a button, and we can throw it in here. And so it's got these really cool kind of layout tools. So if I can center the button by just removing all the anchors, and you'll see there it shows you exactly what's going to happen. So I'm going to save this file now, and I'm going to run this again. And now when I refresh, you'll see there's a button inside that window. And as you can see, it's perfectly centered in the window. I'll show you something more interesting. Let's put in a slider and a text field. So there's a really cool concept in Interface Builder called connections, which allows you to kind of bind objects together. So I'm going to tell this text field to take the value from this slider when it changes. So when I run this again, you'll see that we also have the slider in the text field, and when I move the slider around, it just updates automatically. And let me just steal a menu here. I can throw a menu in here. As you can see, we now have a menu with all the stuff in there. So if we want to edit that menu, we can just open this up and we can add kind of a new item. And oops. And this demo is a little bit hokey, but the Mac people like it, so I'll show you too. This was all the rage back when WebKit was first created. We're going to create a no-line browser. I'm going to grab a web view here. Just drop that in. Now I'm going to tell this web view to take its URL from this text field. So take string URL from. And I'm also going to add a button, a back button. And I'm going to tell the web view to go back when you press this button. And one last thing. I'm going to tell the window not to be visible when I first launch the program. And instead, I'm going to have this menu item, which I called browser, open the window. So order front. So let me rerun this tool. So here's the empty window again. If I go to other stuff here, you'll see browser. That opens up the little browser window. And come in here. There's apple.com. I can go somewhere else. And if I hit back, it goes back. Amazing. So one of the things that kind of UI builders get wrong is that you can basically do what's in the builder and that's it, and then everything else you kind of got to stop using the builder for. But what Interface Builder is really great for is kind of expanding it, and I kind of want to give you a quick demo of how we do that. So let's go to just a new project. So we're going to make a new class. Oh, that's not what I want. So I'm going to make a new class, and so you'll get kind of a feel of Objective-J as I do this too. And to make a class, you use the implementation keyword. And we're going to make a new kind of view that just draws a triangle on the screen. So we're going to call it triangle view. And it is a subclass of the view class. So there we go. And to draw, you implement the drawRect method. This is just like Java and obviously Objective-C. So I've got the snippet of code that draws the triangle here for me. It's not particularly interesting. Basically, we just set the fill color to red and then make a Bezier path that starts at the top center and moves to the bottom right, bottom left, etc. So now that we've got this class here, we have to somehow tell Interface Builder about it. So what we're going to do, let me close this. So we've got a blank one now. We're just going to tell it to use the superclass, which is the view. And I'm going to drop this in here. And I'm going to go to its properties, and I'm going to say, you know what? You're not a view anymore. You're a triangle view. And I'm going to go ahead and set its resize flags as well. hopefully if I've done everything right here. There you go. There's our red triangle. And since the resize flags are set, it's going to redraw, correctly. So now we want it to kind of interact with other controls. So what we're going to try to do is put a color well in there that can change the color of the triangle. So I'm going to make a little more room. I'm going to move this down. I'm going to choose color well and throw that in there. And so before we can change the color of the triangle has to have this idea of a settable color. So I'm going to give it a member variable, which is a color. Now, again, I said that Objective-J is a superset of JavaScript. So as you can see here, I'm doing this in a very strict way, as you would like in Java, declaring all your member variables ahead of time. You don't actually need to do this. It's more of a stylistic thing, like, hey, look, these are the variables I'll be using in my class. So again, you could leave that out and just add it to the class automatically as you would with JavaScript. So I'm going to add a new method called takeColorFrom. Basically, all this does is set its color to whatever color the parameter you pass in contains. And I have to do one more thing, which is notify this view that it needs to redraw itself because the color changed. So normally, when I add a method like this, Interface Builder would pick up on it automatically. But since we're using Sabitha Edit and not Xcode, it doesn't. But there's a really easy workaround to that. I'm going to just click on here and add it myself manually here into the actions. So take color from, that's what I named it, I believe. So now it's got this idea of an action that it can perform. So I'm going to connect the color well and choose take color from. So once again, I'll save it. And rerun this. There we go. So now I've got this color well. Oh, it's not working. Oh, yes. There we go. See, that would have been really easy to find now because debugging is just so great in Cappuccino. There we go. So there we go. Refresh it. There we go. Now it's just going to automatically take the color from the color well. And the other cool thing about Interface Builder is that you're not just limited to interface elements. You can actually kind of create abstract objects on the fly. So let's just create kind of a useless object, but just for demonstration purposes. Let's call it alerter. And it just inherits from the normal object class. And it's got also an action, which is say stuff. And all it does is alert, hey there. So I'm going to come into Interface Builder. And just like before, I chose kind of like the base view class. I'm just going to choose the base object class and just throw it into here. Now, the reason it's going down there is because it's an abstract object, right? It wouldn't make sense to put it in the window. So just as before, I'm going to say, hey, wait a minute, this isn't an object, it's a alerter. So now we've got this alerter object that will be created when we load this interface. And I guess we can add a button to make it say what it wants to say. And again, we have to add the action again because we're not using Xcode. So there we go. And now I can connect this to here. It's not showing up. 1 second. Well, it's not showing up. And
alerter instead of alert? You put alert for the class?
No, that shouldn't matter. I mean, I put this here. Let me try redoing it. I'm sure it's something simple. Oh, there we go. Yeah, I must have misspelled it or something. OK, so now it's in there. And we'll run this tool again. So refresh. There we go. So that's kind of just an idea of how you create applications in the Cocoa world, and thus how you can use those same strategies to create them in the Cappuccino world. Back to presentation here. So you can try out everything I showed you is part of this 0.7 beta. It's actually not in the stable release yet. So you can go to GitHub and try it out. You don't have to remember that URL. You can just go to our normal one, and it's listed in there. This is our website. All this stuff I showed you is completely open source, and you can download the stable release from here. And there's also a link to GitHub where you can try out the betas. Here's some more information. We're always in the IRC room. We have really, really bad sleeping schedules, so one of us is always awake during the day. So you can find us there. And that's it. I have some time for questions now, if you have them.
Are you aware of anyone using Objective-J without the Cappuccino side in an active app?
Yes, but in this kind of non-Objective-J way. They're actually using the runtime to build their own language. I know of at least 3 people doing that. So one of them being that Ruby thing.
So what's the state of Atlas at this point?
We're going to release it in the summer. We're working really hard on it. It'll be done soon. So I guess something I should mention is kind of what's the difference between Interface Builder and Atlas. Well, one obvious one is that Atlas runs in the browser, and thus you don't need a Mac for it. But the other one is that Atlas is a lot more internet-centric, right? Interface Builder was designed for just building desktop applications, whereas Atlas adds kind of this idea of internet controllers where you can just automatically draw those little connections to like Twitter or RSS feeds and that sort of thing. So that's kind of what we've been working on. Another interesting thing is that our plugin API is exactly the same as Interface Builder's plugin API. So all the existing plugins for Interface Builder and the Mac are just going to work with Atlas. So a lot of people have made kind of these really flashy controls for the Mac, and you'll be able to upload those to Atlas and use them too. So.
Do you have built-in support for hotkeys?
Yes. Like arrow keys and like Command C, Command V. That's all built in.
Do you see this working for something like with PhoneGap for making iPhone apps?
Atlas actually supports the iPhone. So one of the ideas we had was nibs, this kind of interface format that exists for the Mac today, is used for localization a lot on the Mac because you can just make a completely different UI for every localization, which is really, I think, the right way to go a lot of times. For example, like in Israel, you might want your entire UI to be completely flipped, right? As opposed to kind of the American one. And we took that same idea and applied it to different platforms. So you can have kind of the same core code and then have a interface file for the iPhone, and that gets launched automatically when it's loaded in the iPhone. And then you have a different interface file for the desktop, and that gets launched automatically. And each one has like its own unique set of widgets. Like there's very iPhone-y widgets for the iPhone, and desktop-y widgets for the desktop, etc. So.
Does Objective-J use the VM of its host, or does it have its own VM?
So the way Objective-J works is that it's a very, very thin layer on top of JavaScript. Again, it's a couple features that we feel it should have had, such as classical inheritance and that sort of thing. So you can actually write Objective-J without Objective-J. If you want, you can use all the library functions to do the same thing. I don't know why you would, but you could. So the way that this kind of auto-magically works, that I'm typing in this new language and it's just working in the browser, is that we actually have the compiler written in JavaScript, and it grabs your code, converts it to JavaScript, and then runs it very quickly. Now, we understand that for some really high traffic applications that can be a little slow, so we actually have a separate compiler where you can compile it all ahead of time and compress it all into one file and do all the crazy things you need to do for the web. So you can choose either one.
If I write my business logic and write an app in Objective-J and then I want to deploy it to the desktop, are there people who are like running Objective-J as the guts of a Cocoa app?
Kind of. So you can obviously just throw a web view into a containing view, but So I didn't really go into this, but Objective-J doesn't use the DOM at all, et cetera. As you saw, I never touched any sort of traditional W3C technologies. And one of the big reasons behind that is that we wanted to be able to build it on top of any graphics library. So one of the things we've been experimenting with is kind of having Cappuccino run entirely on SVG instead. And the other thing we've been kind of experimenting with is actually talking to the native graphics library. So on macOS 10, we could just talk directly to core graphics. So that's definitely another option. That's not anywhere near done, but you could just take the throw a web view into an application approach and have it work.
Current browser compatibility for
So IE 7, 8, Firefox 2, 3, Safari, all of them, Opera 10. Do you have a question earlier?
Are there any apps in the App Store that will be using this right now?
On the App Store, the iPhone App Store? So we actually have one that we shipped that runs Cappuccino. That's it because we haven't released the code for that. But the code will be in there for Atlas. We haven't open sourced that part yet. So yes/no.
How do docs and tests, like you can go into the
Yeah, so we have our own little custom testing suite. It's called OJ Unit. It's in the just the GitHub tree if you want to look at that. And for documentation, it's admittedly a little sparse, but the nice thing about the documentation is that all the Apple docs for Cocoa are exactly the same since it's the exact same API. So you can go to developer.apple.com and that's pretty good documentation.
But everyone would like to thank Francisco for